Okay, so first thing, there's a change in plan for our timeline here. Originally, I had planned to do the energy conversion lab tomorrow, but I booked the Chromebooks for last Thursday. So that was kind of a mistake. So now we're going to do that on Tuesday instead, because that was the earliest I could get the Chromebooks. Because when you wait till the last minute, you have to take what's there, and it's usually at least a week out. So we'll be doing that lab on Tuesday, which is the day before your unit exam. So obviously I won't be asking for that report, okay, like the next day or anything like that. Not that I would ever ask for it that quickly anyway, right? So that's going to change that, okay? It isn't going to change your exam date. We're definitely going to be done everything we need to be done, okay, probably by Monday. So we'll do probably the unit exam review on Monday, okay? Unless we do really well today and tomorrow, and then we'll do it on Friday. Okay, let me ask you this. And this is not meant to be like a disturbing or violent question, okay, it's a physics question. I have 2 bullets. One of them I'm holding, the other is in a rifle. They are right beside each other. I pull the trigger on the rifle and drop the bullet at exactly the same time. Which one hits the ground first?
The one you dropped.
Yeah,
because the rifle wouldn't also depend on the caliber.
They're identical bullets.
Is the rifle aiming?
The rifle is aimed horizontally.
Oh,
When you drop, because it's
Rotating.
just the
thought
bullet, it's
you were-
the bullet and the casing.
I thought you were.
Nope, mass actually doesn't affect how quickly something falls. If I dropped a bowling ball, it would be the same. I just used identical bullets for the sake of having everything very identical.
Rotating.
But you're right, I mean, one would, it would still have the round on it, like the casing, yeah. But actually, that wouldn't make any difference.
Rotating objects.
Wouldn't the bullet in the in the gun be shot a lot further and like have less force going down? I guess I don't know.
It would go further. I'm not saying they would hit the ground in the same place. They definitely would.
I thought you were pointing back.
No, I mean, like, I'm pointing the rifle perfectly level, horizontally, okay? And the bullet is right beside the chamber, okay? And I pull the trigger and drop the bullet at I have a machine do it, so that they're dropped at exactly the same time. Which one hits the ground first?
Although, it's at the same time.
They hit at the same time.
Spinning objects resist changes in motion, don't they? So the rifle on them. Yeah, because most bullets are rifled.
That actually doesn't make any difference either. That just helps them to travel through the air. Gravity pulls them both down equally. Okay? All things fall at the same rate. I could have dropped a bowling ball and shot the bullet. They'd hit the ground at the same time. They have to fall the same distance. Everything falls at 9.81 meters per second squared in the perfect physical world. Obviously, if I drop a feather and a bowling ball, they don't, the feather does this and the bowling ball just falls to the ground because of air. But if there was no air resistance, the bowling ball and the feather would fall at exactly the same rate.
Since the gun makes sound, wouldn't there be a loss of energy? So
The gun only makes sound because the cartridge, the powder in the cartridge is detonated. That's not a loss of gravitational potential energy. They have exactly the same gravitational potential energy. Okay, and that energy actually doesn't affect how fast they fall to the ground. Okay, they would actually hit the ground at the same time, not in the same place, obviously. Okay, but they would hit the ground at the same time because all things fall at the same rate. That's why when we were doing that question yesterday, why mass canceled off. Okay, how fast something goes due to gravity has nothing to do with its mass. Okay, because all things fall at 9.81 meters per second squared. Okay, I'll prove it to you. Just because one of those bullets I was talking about is going to move horizontally doesn't mean it doesn't move vertically as well. Gravity still affects it whether it's moving horizontally or not. Okay, they both have to accelerate towards the Earth's surface, and they both do that at 9.81. Okay, in fact, that's what makes like any kind of target sport tricky. Okay, whether it's archery, okay, or like shooting or anything like that, okay, you have to correct for drop. Okay, I think we talked about this the other day, right? Like the longest sniper shot being just under 4 kilometers. Okay, that means you have to account for a lot of drop. Okay, and quite frankly, wind, and also the rotation of the Earth.
And the curvature of the Earth.
Yeah, like the Coriolis effect, and at 4 kilometers, yeah, you also have the fact that the Earth, over 8 kilometers, so over 4 kilometers, the Earth would curve downwards 2¼ meters, because the Earth's round. Okay?
No, I think.
So there's a lot of things, and because the Earth is spinning, okay, there's even on a shot that long, the effect of the Earth rotates under the bullet. Okay? At that distance, you even have to account for that. Okay? It's pretty crazy, right? But what it comes down to is everything is going to be affected by gravity in the same way. Okay? Now, does that mean that, you know, a bowling ball and a feather would have the same amount of potential energy? No, not at the same height they wouldn't, because the ball has more mass. Okay? But that mass doesn't change how fast it's going when it gets to the ground. Okay? It'll still have more energy when it gets to the ground because of its greater mass. Everyone follow me there? Okay? I mean, think about it. If you see a bowling ball falling and a feather falling and one of them has to hit you, you pick the feather. Okay? It's not going to hurt you. Okay? It doesn't have as much energy. Okay? It's going to be going just as fast. Okay? But it's not going to hurt you because it doesn't have the same amount of ability to do work. Okay? All right. I would like you guys to try this one. So this is very much like the sledding question we did yesterday, but it's my awful drawing. Okay, so here's the situation. I have a 1,600 kilogram roller coaster at the top of a 50-meter high hill, moving at 5 meters per second. I want you to calculate for me how fast it would be going here when it is only 8 meters above the ground. Okay? And I will tell you that this is a law of conservation of energy question, very much like the one we did yesterday with the sledder. The one we did yesterday with the sledder, we had to find the height. This time you're looking for a speed. Okay? Give you a few minutes on that one. Okay? See if you get it, and then we'll walk through the steps. So if you didn't get this one, make sure you copy down what we're doing here, because this is a prime example of a conservation of energy question where you're being asked to calculate a speed. Yesterday's was a prime example of how to calculate a height. And really, those are the only two ways one of these questions can go. Okay? Now, in this situation, okay, my initial mechanical energy and my final mechanical energy are the same because this is a physically perfect roller coaster with no friction, okay, and there's no work being done anywhere. All of the energy is going to be conserved between point A and point B. Okay? Now, how do I calculate mechanical energy? Oh, that'll calculate work. What two things do I add together to get mechanical energy?
Potential energy plus kinetic energy?
Right. Okay, so that means then that my initial potential plus my initial kinetic equals my final potential plus my final kinetic. Okay, once I've written that, I need to look at the situation and determine, are any of those forms of energy a value of 0? Okay, so initially, do I have potential energy? Yeah, I'm 50 meters above the ground. Definitely have potential energy. Do I have kinetic energy initially? Yes, moving at 5 meters per second, so I have that. Okay, next thing, at the end, okay, I'm 8 meters above the ground, so I have still potential. Okay, and they're asking me to calculate speed, and given this situation, I would have kinetic energy, agreed? And I'm lower, I should be going faster at that point, so that's not 0. Okay, so all of those are not 0, I can't cross any of them off. What I'm looking for is VF, which is going to be part of that term. So I want to start by getting that term by itself. How do I get that term by itself?
Subtract the initial potential final energy.
Exactly. Subtract potential final energy over to the other side. Okay, so I'm going to have potential initial plus kinetic initial, or the mechanical energy, minus the potential energy final, should give me the kinetic energy final. Okay, can I put in my formulas now? Okay, so potential energy is m times g times h initial plus 1/2 mv MV initial squared, okay, minus MGH final equals 1/2 MV final squared. Okay, I'm looking for V final, but is there something I can get rid of right now?
The math.
Mass. Mass is in every term, and speed doesn't depend on mass, so I can cancel it. If you don't want to cancel it, you can leave it in there. Okay? But I like having less stuff to punch into my calculator because it's less chances for me to screw up. Okay? I want VF by itself. What do I do with the half? Divide both sides by a half. Okay, so that's gone. I want VF, not VF squared. Square root. Okay, that's about as complex of algebra as you're going to get in this course. Okay, it's having to do a manipulation like that. All right, now that we have that, now we need to plug in our numbers. So we're going to have 9.81 times 50, so that would be my initial potential, okay, plus 1/2 times 5 squared, my initial kinetic, minus 9.81 times 8, my final potential, right? All divided by 1/2 square rooted to give me VF. Okay, everybody all right with what I did there? All right. If you show all of these steps, this is probably a 6 to, depending on how generous I'm feeling, 8 mark question, probably 6. Okay, if you show all of this work and then punch it into your calculator wrong, can you still get 5 out of 6? Okay, is it important to show your work? Yes. Okay. Oh, sorry, I forgot to turn on my calculator, guys. We have to wait for the hamster to wake up. There you go. Okay, so on this one here, okay, we're gonna have, and I wouldn't try and enter this all at once, do it a piece at a time. 9.81 times 50 plus 0.5 times 5 squared. Okay, minus 9.81 times 8 divided by 1/2, square root that. All right, so that's pretty fast. Okay, 29 meters per second, because actually we would only have one significant digit.
2.9 times 10 to the
One significant digit. 3 times 10 to the 1 meters per second. I would never do that. I'm going to give you one that had one significant digit. So 29 meters per second, which, just to give you an idea, guys, means that roller coaster is moving at 104 kilometers an hour.
So it's moving.
It's moving, yeah. Okay.
How fast are regular roller coasters?
That's on the fast side. The Mindbender used to go about 80, I think it was 85 to 88, okay, when it was at the bottom of the first hill, okay, before they took it apart. All right, questions on how that worked? Okay, so you can cancel mass or not. It doesn't make any difference. Okay, if I did that whole thing over again and had 1600 in for M, it would get exactly the same answer. Okay, and I once actually had that happen on the unit exam. I forgot to put a mass in for the question, because I'll always put it in there just because people feel better if they have it. Okay, but I forgot to put one in, and a kid came up to my desk and, Mr. Codere, I think you forgot to put the mass in this question. And I'm like, yeah, you're totally right. So what do I use? I'm like, knowing it doesn't matter. 500 kilograms? Okay, and it sits down. A few minutes later, another kid comes up. Mr. Codere, I think you forgot to put mass on this question. I'm like, yeah, I couldn't remember what number I'd given the first kid, like 1,200 kilograms. And there's a few people doing exactly that, and they're like chuckling, and I'm like, oh. And then I look out and I can see there's kids chuckling because they realize the mass doesn't matter, and then there's kids that are like, you just gave them different masses. Is he screwing with them? Like, is he trying to mess with them? Is he like, it didn't matter. So I ended up having to go, guys, I forgot to put the mass on. let's just say that it's 1200 and everyone can be fine. And then everyone was fine after that, but I could see that a few people got really panicked and I had to like settle that horse down a little bit. Okay. But yeah, mass doesn't actually matter, but I will always give it to you just because people feel better if they have it. Okay? All right, so that is as complex as they get. Okay, having to solve for V is harder than H because you have to remember the square root. Otherwise, the algebra is pretty much the same. Okay? All right. Try this one. It's just like the one we did yesterday, except it doesn't have my crappy drawing, which probably makes it better. Okay? You could draw it if you wanted. That's a good way to show your givens. Okay? Is to draw the picture. All right, so we got a toboggan going down a hill. So there's our hill, okay? There's our toboggan. I'm not going to bother drawing a person on it because that will test my artistic ability. Okay. So at one point, it is 30 meters above the bottom. Okay, and moving at 14 meters per second. Okay, shortly thereafter, the sled is moving at 23 meters per second. Okay, how far above the bottom is it? So we're looking for the final height. Okay. Now, since it doesn't mention the word work or identify any forces that could take energy away, can we assume that all energy is conserved? Yes. If you don't see the word work or force and distance or anything like that, you can assume that energy is being conserved. All right, so EI equals EF. That's going to mean EK initial plus EP initial equals EK final plus EP final. Okay, any of those zero? No. Okay, they all have a non-zero value. All right, so I can't cancel any of them off. What I'm looking for is final height, which is part of that. What do I do with EKF? Subtract it over to the other side. Okay, so EK initial plus EP initial minus EK final equals EP final. Okay, and then I can put in the formulas. 1/2 MVI squared plus MGHI minus 1/2 MVF squared equals MGHF. Okay, were you told the mass of the toboggan? Does it matter? No. Okay, so if I don't give it to you and it really makes you uncomfortable, pick whatever you want. It won't make a lick of difference what number you put in for M because M is in every term. And I'm just going to cancel it. All right. I want HF by itself. What do I do with G? Divide both sides by G. All right, then we plug in our numbers. Okay, so we're going to have 1/2 times 14 squared, our initial, okay, plus 9.81 times 30 minus 1/2 times 23 squared, our final kinetic, okay, divided by 9.81. 0.5 times 14 squared, okay, plus 9.81 times 30 minus 0.5 times 23 squared, okay, divided by 9.81. All right, tells us that it's descended quite a ways. Now it is only 13 meters above the bottom of the hill. Okay. How patterned are these questions? Very. Okay, so really, if you know the pattern, it's not very hard to do. Okay, the most challenging part of this is probably the algebra. Okay, just being able to move the stuff around correctly. Okay, second to that would probably be punching it into your calculator without making a mistake. Right? Now, if you do make a mistake punching something into your calculator, it will probably be fairly obvious. Okay, like if you forget to square something, your number is going to be quite small. Okay, or if you forget to square root something, your number is going to be kind of ridiculously large. Okay, make sure that your answer makes sense within the context of the question. Okay, I will never give you a question where the answer is nonsensical. Okay. All right, how are we feeling about that stuff? I hope you're feeling okay about it because you're definitely going to have one of these on your unit exam. You
We
have
have
two.
one on our quiz.
Thursday's good, definitely. Okay, you're gonna have two work energy theorem questions, one about potential, one about kinetic, and you're gonna have a conservation of energy question for sure, okay, in that part, in the written part of your unit exam next week. Okay,
How did I start thinking about the reader?
Okay.
I really wanted to read.
try this one. As we go further along, the questions become more and more violent. Okay, so for number 2 here. Car drives off a cliff. That's what they do, okay? They arc down to the ground, okay? So we know that they drive off the cliff at 25 meters per second. So that's going to be VI. Does it matter that that is horizontal? Nope. Energy is scalar. If you're moving, you have kinetic energy. Doesn't matter how fast. Okay? All right. When it strikes the ground below, it's moving 53 meters per second. So VF would be 53 meters per second. What's my final height? 0. Does it ever outright say that anywhere? No. Well, it kind of does. When it strikes the ground, okay, so we know we're dealing with the ground, that means the height is 0. So we're looking for, here, the height of the cliff, which is the initial height. Okay? Since it doesn't mention anything about air resistance or anything like that, then we can assume that energy is being conserved and that initial mechanical equals final mechanical. All right, so that's going to mean initial potential plus initial kinetic equals final potential plus final kinetic. Okay, any of those 0?
Yes.
Final potential is 0 because if we're on the ground, our height is 0 and m times g times h would then be 0 as well. All right. So what I'm looking for is part of this, the initial height. So what do I do with EK initial? Subtract it over to the other side. Okay, so I'm going to have initial potential equals final kinetic minus initial kinetic. Okay, can I put in my formulas now? Okay. Could I put in my formulas before and then do this subtraction thing? Could do that too, it doesn't make any difference. Okay. M times G times H initial equals 1/2 MV final squared minus 1/2 MV initial squared. M's are going to cancel. I was never told the mass of the car anyway. Okay, what do I have to do to get HI by itself? Divide by G. Okay, so when we plug in our numbers here, okay, we're going to be looking at H initial being 1/2 times 53 squared minus 1/2 times 25? 25 squared divided by 9.81. Whoops. That's not what I wanted. Minus 0.5 times 25 squared. Okay, and then divide that by 9.81. All right, so it's a 111 meter high cliff. Actually, we only have 2 significant digits there, so it would be 1.1 times 10 to the 2 meters. Okay, making sense? All right, I'm going to show you a video here. It has to do with acceleration, energy, work. So, from a conservation of energy standpoint, okay, for Michael Jordan to jump as high as he does, okay, he's got to exert a force where?
On the ground.
On the ground. What does the ground do? It exerts a force back. Okay? This is counterintuitive, but to jump, you actually push down.
Yeah.
Okay? Everyone thinks, well, if I'm jumping, I push up. No, you don't. You push on the floor. You push really, really hard on the floor. And the floor has to push back because of Newton's third law. Every action has an equal and opposite reaction. So if he pushes hard on the floor has to push just as hard back. So hard, in fact, that it throws him up into the air. Okay? So it's actually the floor throwing you into the air. Okay? That makes you jump high.
I thought that man just took 12 minutes telling us that we could jump 45 feet.
Yeah, it's good one to go, need to go. I'm surprised they never show his jump from the free throw line.
Yeah,
Jump.
I was about to say.
Okay, but I mean, that's not about height, it's actually about distance. It's more of the long jump thing that they were talking about, right? You have to transfer that energy horizontally as opposed to vertically. And in every jump test, except the one where you just stand and jump straight up, there's always a horizontal component to it. But you get that extra momentum because you're running. Okay, and that's kind of where that extra energy comes from. So on that note, that's what I wanted to go over. Okay, back to the idea of energy is scalar. So it doesn't matter if you're moving horizontally, vertically, or at an angle, your kinetic energy is based on your speed, not which way you're going, just how fast you're going. And that determines how high you can jump. Okay? Making sense? All right. Okay, so this is another one that's like that. You got to think about that whole, is the direction of the movement important for what's happening here? Okay, so skydiver jumps out of a plane. The plane's moving at 90 meters per second and is 10,000 meters above the ground. How fast will the diver be falling when he is 8,000 meters above the ground, assuming he has not opened his parachute? Okay, because if you've opened your parachute, then you're not going to accelerate at 9.81 meters per second squared. Okay, we can only deal with the part where he's in free fall. So he's in free fall for 2 vertical kilometers. So this would be a halo jump. Okay, high altitude, low opening. All right, give that one a try. We'll call it a day after this. So for this one here, guys, okay, the person is falling, okay, but they're moving horizontally at 90 meters per second. Does it matter that it's horizontal? No, but I catch people on that sometimes on tests. Okay, they realize that if they jump out of a plane, the plane was moving horizontally, so were they. And they're like, well, I'm only worried about the vertical part because they're falling. That means their initial speed is 0. No, it doesn't. Okay, their initial speed is 90 meters per second, same as the plane. Okay? In fact, if this was the perfect physical world, okay, and someone jumps out of a plane, they move along with the plane. Okay? It's why if you're in a bomber, you don't fly straight and level after dropping the bomb. Because otherwise you'll be right over top of it when it detonates. Okay? So a bomber drops a bomb and then turns and goes the other way because you don't want to be over top of a bomb when it goes off. Okay? It's going to move at exactly the same speed you're moving, okay, as it falls. And that speed is important for its energy. Okay? So same as the others here. Okay, we're looking for how fast they'll be going when they're at 8,000 meters. Okay? So EI equals EF. Okay? We have all the kinds of energy. So we'll have, we're looking for the final speed. So we'll have mghi plus 1/2 mvi squared minus mghf equals 1/2 mvf squared. I know I'm skipping a couple steps here, guys, but okay, the m's are going to cancel. Okay, divide both sides by 1/2 and square root. Okay, that'll give you your vf. Okay, so that'll be 9.81 times 10,000 plus 1/2 times 90 squared minus 9.81 times 8,000 divided by 1/2. So 9.1 times 10, 3, 4, 8 equals plus 0.5 times 90 squared minus 9.81 times 8,000. So I'll have it here in just a sec, guys, so you can check your work. Okay, divided by 0.5, square rooted. 217. Okay, you're going to get at least 1, if not 2 of those tomorrow. Have a good day.